I do that all righty. And how we doing on time? I know Elizabeth is going to join us. And it's tricky too. This is like vacation time for a lot of people. So I'm sure a number of people are on their way out of town for 4th of July. I am sure. We got another chat. One of my colleagues is here from Texas. Awesome. All righty, so it is 5:30, so we're going to go ahead and get started. Welcome everyone. Thank you so much for coming and spending a little time with us this evening. This is our last session before we take a little break. We're going to take a break the month of July, and then we'll be back in August. So just want to give you a couple of notes about what we're doing. So for those of you who are new to our professional learning series, we have about 2 talks a month. This month is special because we've been doing a whole series on content and language instruction. Typically, the series is reserved for Georgia TESOL members, but some of our sessions are public, this being one of them. And so, of course, you're welcome to all public ones, but if you want to avail yourself to all of them, plus all of the past recordings, you have to be a Georgia TESOL member and you can join. You do not have to be in Georgia to do that, but just join and you can have access to all of our videos. If you are a Georgia TESOL member as well, we now give certificates of participation. So if you can use that towards your professional development as you renew your certifications, etc. We're a little behind, so if you haven't gotten anything for the last month or two, we'll catch up, I promise you. We had an end of year Georgia TESOL social where we were all over the state meeting in different places. I think we may have another one before the end of the year. But again, we're going to be taking a break in July because every teacher, educator, etc. deserves a break during the summer. So we're going to take a little break. Just to highlight some of the special sub-series we've been doing. So like I said, we are at the end of the content and language integration series. Tonight's the last night. We're dealing with math, Ye Math. And then we've been having a student, parent, and community empowerment sub-series going on all year. The next installment will be in August. So feel free to come back where we're going to be talking about parents' rights and responsibilities. I think it might actually be in Spanish because we really want parents who for speakers of other languages to join. So we may actually do it in Spanish and have English subtitles. So that might be fun. So feel free to join us, invite parents. That's a public one as well. And then our last public one for the year is going to be this one on thinking about pathways for multilingual learners beyond high school. Tonight, this is so weird. We're going to be, like I said, we're going to be doing our last installment on the content and language integration series, featuring myself and Ye Na Parrett from Georgia Department of Education. And without further ado, we're going to get started. So we're going to start this lovely slideshow. Okay. So welcome to our lovely talk about making visible mathematics visible for our multilingual learners, specifically through the key language uses. And we're going to target 2 of those tonight because there's not enough time to cover all 4. So we're going to start with a process called reader generated questions. And so on your own, I want you to take a moment and write a few sentences, or not sentences, but questions that you think would go along with this figure that I've put up. So just write down as many questions as you can that you think would go along with this figure. Give you a few more seconds. Okay, so what I'm going to do now is going to put you in breakout rooms, and your next task is to, actually, you've already done that. You're going to share your questions with your small group, okay? I just want you to do that real quick. So hit join, and you're going to take a moment and share the questions that you generated with your group. A couple people. Oh, Michelle's in the wrong, is in a group by herself. I don't know how that happened. I'm going to move her. Make sure everybody's with somebody. Close all the rooms. All right. So how did it go? Did you all have similar questions?
Yes, we did. And we talked about how also it depends on, you know, maybe your grade level of the students, how you would, what kind of questions they would ask or you could ask.
Mm-hmm. Very cool. Anyone else want to share? Okay. So in a regular math classroom, I would go to step 3, which would be having you solve each other's problems, but we don't have time for that tonight. So the next step, though, is to present the actual text. So if you have a QR code reader, you can go to it here, and I'm going to display it on the screen as well. So this is a problem from a standardized test in Massachusetts. It is 10th grade, actually, just in case you were wondering. So they present it as a puzzle in the shape of a rectangle that has 6 pieces. And then the students are asked to first find the perimeter of the whole puzzle. And then they start asking about the area of individual pieces. So they start with B here, which at the very least is a parallelogram, might be a rhombus. And then R is a trapezoid. They ask for that area. And then P is this triangle here. How did your questions compare? Did you all ask for the similar things, perimeter, area, those questions, those kind of questions? Give me a thumbs up or so. If that was kind of along the line, what you did. Awesome. Awesome. So at this point, we would, again, check your responses, see how accurate your questions, etc. were. And then the last part would be to give students another one and have them do this process again. So questions for you guys, and you can take yourself off mute and just answer. So how might an exercise like this benefit our multilingual learners?
Has like multiple entry points that they can see, like the letters, they can see those letters from alphabet and the numbers.
Mm-hmm. Mm-hmm. Thank you. Anyone else?
Well, I was just going to say it's a good visual for them. Most of them are helped with visual aids.
Mm-hmm. Mm-hmm. Good, good. Second question, what key language uses might be occurring with this problem?
Yeah, definitely, if they're in groups, they'll be speaking and listening to each other.
Mm-hmm. So which key language use would that be?
I think that they would have to explain.
A lot of, yes,
Explain.
they have to explain
Yeah, a lot of
to each other.
explaining.
Mm-hmm. Mm-hmm. Good, yeah, any others? Okay, one more question for you. But which you've already started talking about, how is the visual assisting in the content and language learning? And I think Lily said there's multiple entry points based on the visual, and so that Pamela alluded to that as well. So we won't spend time on that question, but just want to get you thinking about some ways that you might provide entry, and you can use any visual you want with that particular process. So that was our warm-up. We're going to talk a little bit about the language of math and what WIDA says, the importance of visuals. And then we're going to go into some of the key language uses, specifically narrative or narrate and explanation. And then we're going to bring it all together and think of and talk about what's happening at Georgia DOE. So thinking about the language of math, one of my favorite researchers or group of researchers, Marks and Mousley, talked specifically about language uses in mathematics. And he talked about how mathematicians use language to make meanings and understandings, and that students need to develop control of the different genres that are present. And with that, we, the teachers, have to embrace the range of genres that exist in mathematics. So it's much more than just procedure, much more than just recounting. There's all of the genres happening in mathematics if we really embrace the language that exists. So thinking about the different kinds of the different aspects of language, we have different levels of terminology. So your tier 1, tier 2, tier 3 terms. Then you have grammatical patterns. Who knew that mathematics would be full of prepositions and conjunctions? But it is, and they all mean something. There's implied relationships a lot of times. We don't, you think about word problems in particular, we don't tell you that you're going to have to add something. We just say, well, how much is that all together? And so there's all these implied relationships, implied operations that exist in mathematics. Multisemiotic systems, meaning that you have systems that mean multiple things. So we've got symbolic notations, we've got graphs, we've got verbal language, all these different things. And then, of course, we have homonyms and homophones. We've got word clusters, idioms, all these lovely things. Nominalization are happening. There's a lot happening in mathematics that goes way beyond numbers. Today, of course, we're focusing on visuals. So that being said, let's take a step back. This notion of using visuals in mathematics is not new. So the NCTM process standards, National Council for Teachers of Mathematics, they have been promoting the notion of representations for at least, I think it goes back to 1990, so 30 years or so, and really been hitting that. Then Common Core comes along and emphasizes it even more and says that everyone should be modeling with mathematics. Students are required to model with mathematics. That's the interesting thing about the standards for mathematical practice, because they're worded in a way that the students are actually supposed to be doing things, not just the teacher. So that's really key. And so, of course, with modeling, we're talking about visuals in different ways. And there's other things that other standards also that tie into that, but specifically modeling does. And so when we think about modeling, here's an example of thinking about fractions and decimals. So you can represent fractions and decimals in a lot of different ways. You can use circles, area models, base 10 blocks, number lines. None of our students are too old or too young to use models in mathematics. And that's a really key point as well. And the nice thing is when you use any kind of visual in mathematics, you're also looping in multiple intelligences, whether that's visual, spatial, sometimes kinesthetic, if it's actual, if you're using tangible manipulatives. And you're also thinking about, you're incorporating multiple means of representation, which is UDL. So by incorporating one thing, models, visuals in mathematics, you're actually hitting a ton of different standards, guidelines, frameworks, etc., in one stroke. With that said, Jo Bowler and some of her colleagues got together, did some work in this one study. And one thing they noticed was that after 4 15-minute sessions of playing a game with a number line, the differences in knowledge between students from low-income backgrounds and those from middle-income backgrounds were basically eliminated, which hits NCTM's equity principle as well. So this is a huge deal that visuals and modeling can actually even the playing field, which that's an amazing thing. And that's just 15 minutes. So what happens if we do that 15 minutes every day or every other day? So we're looking at possibly, I won't claim elimination, but definitely reducing the achievement gaps between our different subgroups of students. So their recommendations: encourage visual approaches and replace memorization as primary markers. Again, we're targeting the multiple intelligences. Encourage finger use is not babyish. They actually have a study that adults who use their fingers to do mathematics tend to be more successful than those who don't. So finger use is good. It's not babyish at all. And then there is nothing in mathematics that cannot be visualized, whether that's interpretively or expressively. Okay, so everything in mathematics is capable of being represented in a visual manner. This being said, let's look at what WIDA says. So WIDA has a guiding principle, number 6, that talks about multilingual learners developing language activities. when you're talking about multiple modalities, including oral, written, and visual and kinesthetic modes of communication. This is huge. Then there's a whole section in the page 200s that talks about the content and language integration, and they talk about connecting to familiar experiences, which often is visual, allowing multiple options for students to share their knowledge, using visually supported keywords, sketches, charts, other visual supports, conceptual webs, those are visuals, visual displays and portrayals, and use charts. If you notice, first of all, let me go back. So this notion of multiple modalities is repeated throughout the WIDA guidelines. It's all through it. But then if you notice under this piece, under the content and language integration piece, that's 7 different points that relate to visuals, and there's 14 points total. So half of the points about content and language integration have to do with visuals in some way, which indicates to me that's pretty important, something that we need to really consider. All right, so with that said, let's dive into our key language uses. So narrative, typically the point of narrative is to entertain or to gain and hold the reader's interest in a story. And that can be informative. It does not have to be just pure entertainment. It can also be thinking about it, reflections, and having it be, I would say, nonfiction, if you will. So again, it can be imaginary or factual, and it includes all different kinds of texts. The typical organization is, or you start off with some sort of introduction or orientation, something happens in the middle, and then there's a resolution. However, in mathematics, you typically are given a framework to find the resolution. It's almost like one of those science fiction novels where you pick which direction you're going to go in next. That's kind of what you do in mathematics. You kind of decide what the resolution is going to be based on your computations. So what does this look like? A lot of children's literature and stories, mathematics autobiographies. You can look like that. It can look like word problems, all these different things. And there's more. That's just a sample. So I'm going to hush for a minute. Think about these 3 different problems. And what do you notice? You can write it in the chat, or you can get ready to share verbally, either one. Okay, so we've got a couple of people noticing the numbers and how there's some implied relationships. The 2 glasses of lemonade, that means you have to divide up the $1.35. They all tell a story in some way, people are saying. Anybody else want to add to that? So do they all have introduction to them? Introductory sentences? Let you know what's going on? They don't start off with once upon a time, but they start off with something, right? Okay, and then there's some complication, there's more happening. So not just, that Jane has 9 dolls, but her friend has 5. And then not just that Stephen and Cooper order pasta, but there's tax and there's other things going on, so there's other complications going on. And then of course, all of them ask a question to help you find a resolution. So someone else said that they grow in complexity as we go up. That is absolutely true. But the point is that we begin learning mathematics through stories at a very young age, and that it continues. It never stops into college. It never, ever stops. So narrative is a very important genre, and I really feel like it's the gateway to mathematics in many ways. So let's keep going. So what are some other reasons for integrating narrative in mathematics? It helps children learn concepts and skills, provides a meaningful context. We talk about authenticity all the time in mathematics and in learning at this point. We want students to have authentic experiences, etc. Helps to develop develop and it helps students use language. Develops the problem solving, reasoning, and thinking, provides a richer view of the nature of mathematics, and it improves attitudes, which we all need our students to have good attitudes towards math. We even need good attitudes towards math sometimes. So there's no bad thing about incorporating narratives or having students do narratives. So the Department of Education uses this framework for planning mathematics, thinking about engaging, exploring, applying, and reflecting. And so one of the ways you can engage students in narrative is a process called the 3-read strategy. I don't know how many of you guys have heard of that, but the nice thing about the 3-read strategy is that it has students, instead of giving students a problem and say, hey, go through and highlight the information, a lot of times they don't know what to highlight because they don't know what the problem is even about. So the 3-read strategy gives them a way to strategically read the problem and read it more than one time. So the first time they read it, it's for context, just what's the problem about. The second time they read it, it's what are you trying to find out? Then the third time they read it is when they actually highlight things. And I've seen students like basically highlight a whole paragraph if you don't tell them to do it in this way. So, because like everything is important, but it's not true in math. There can be a lot of extraneous information. So the 3-read strategy is a great way to get students engaged. Another way of presenting the 3-read strategy is using the Freyer model and then using the 4th box to have students think about a strategy. So that's another way I've used the Freyer model and the 3-read with students. And I use it in the middle school, actually, in particular. And the fun thing about using the Freyer model in this way is that students tend to be used to the Freyer model because they've seen it in other classes like ELA to dissect vocabulary. And so when they see the model itself, they automatically know, okay, we're going to pick something apart and think about things strategically. So that's kind of nice. Another way to incorporate visuals, thinking about exploring. Bar models or tape models help students explore a particular problem or scenario. Here in this one, you can actually think about, and it actually relates to the next piece as well, about applying and presenting authentic scenarios. There's things you can pick out about this bar model just by looking at it, right? So you have some girls, you have some boys. How many are there in total? Yep, there's 253 in total. We know that there's 134 girls. There's a question mark for boys. That must mean we got to figure it out, right? And we didn't have to use a whole set of language even to figure to do that. So I can either present this to students, or I can present a problem in words to students and have them create these kinds of diagrams. And we'll talk a little bit more about that in a moment. And then in terms of reflecting, you can have students justify their solutions using visuals or even create their own stories. So I could give them this visual with the bar model and have them create their own story. What do you think is happening there? So that being said, I just want to add one more thing, which is that technology can really help when it comes to visuals. There's a lot of platforms you can use, whether it's PowerPoint, Google Slides, UDL. CAS has a site called UDL Book Builder, and you can actually create your own books that can have students do things in pieces. You can use Flip, formerly Flipgrid. There's assistive technologies like GeoGebra, TI Inspire, Microsoft Excel, or Google Sheets. But there's also a program called Desmos, which hits both. So Desmos has online calculators, but it also has a feature called Activity Builder, which I highly recommend you take a look at. And it uses a ton of visuals in it, and that can help students navigate mathematics. So I would say take a look at that one. And just to wrap up this section on narrative, so I love this quote, narrative is the heart of making sense of the world. And so if you think about the origin of mathematics, the numbers did not come first. We started thinking about real life scenarios and how could we represent them? The numbers came second. The issue was how can we represent what's happening in real life? So when we're talking about making sense of the world, we start with the scenario and then we go to something symbolic to help us come back and make sense of what was happening. So just want to end with that part. All righty. Okay, so we're going to go on to explanation. I skipped it, sorry. Okay, so talking, oh, sorry, that's a question. Go ahead. Okay. So purpose of explanation, we want to know how or why something works, right? So this tends to have a process focus. We tend to be concerned with a logical sequence. What do these look like? Mathematical tasks, including word problems, also multiple representations. For instance, this one in the picture. So I'm trying to think about how or explain how squared numbers works. And I can go from using the Legos to writing it in multiplication form to writing it in terms of the squares, which is important for students to learn. And then of course, there's the simplified version of that. So we can have students work in small groups, have whole class discussions, or maybe they can do presentations. We can have them write about what they see, or use symbols or diagrams as well. Now, visuals, again, are key. Why? Because there's things we can tell that are happening before we ever put words to it. For instance, what's happening in this scenario?
Throwing one in alphabetical order.
Okay, so we might be going in alphabetical order. There's definitely an order or a sequence happening, right? So this could be equivalent to thinking about order of operations, how you go start from grouping and then you go to exponents and, oh, my exponents are missing, sorry. And then, and then it's either multiplication, division, and then it's addition or subtraction. So that's one way. Then we have this scenario. What's happening here? So you got A, B, C, D in a circle. What's happening?
A cycle of some kind.
A cycle of some kind, exactly. So this could be, and this is all in words, sorry about that, but the guess and check process in mathematics is very much a cyclical situation that we could represent in that way. So this is one scenario where you could guess and check in an equation. And then here we have a hierarchical scenario. And here's one of my favorites, thinking about how to categorize quadrilaterals. And I could use pictures as well. But quadrilaterals can be categorized in terms of the number of parallel sides. And so I have my 3 little columns, and then I have examples of quadrilaterals under each one of those categories. So there's things we can see when we have when we have visuals that we may not be able to see, that will help break down the language barrier, if you will. So we're going to do a problem together. It's called Sarah's Candies. And we're going to do a 3-read with this. I normally don't show it, but I'm showing it tonight. So I'm going to read it through, and then I want you to think about just the context, okay? So here we go. Sarah had a bag of candies. She gave 1/3 of her candies to Rebecca. Then Sarah gave 1/4 of the candies she had left to John. After giving candies to Rebecca and John, Sarah had 24 candies left in her bag. How many candies were in the bag to start? So what is this problem about?
Sarah and her bag of candies.
Sarah and her bag of candies, absolutely. So let's read it a second time. So Sarah had a bag of candies. She gave 1/3 of her candies to Rebecca. Then Sarah gave 1/4 of the candies she had left to John. After giving candies to Rebecca and John, Sarah had 24 candies left in her bag. How many candies were in the bag to start? What are we being asked to find?
We're being asked to find how many candies are left.
Awesome, awesome. So now, wait, how many are left or how many we started with?
How many we
How many
started
started
with?
Right. So we're stuck, but we got to go back and figure out how many we started with. So now we can go back and read for key information. So Sarah had a bag of candies. She gave 1/3 of her candies to Rebecca. Then she gave 1/4 to John. After giving candies to Rebecca and John, Sarah had 24 candies left in her bag. How many candies were in the bag to start? So I'm not going to have you tell me key information, but what I am going to have you do is draw a diagram that you think will represent the important information. So I'm going to give you a moment to do that. You remember, you're not trying to solve it. You just want to represent the important information. Do not try to solve. Okay, I'm gonna take you to the next step, which is to compare your diagrams with each other. So I'm gonna put you back in breakout rooms for a moment. So here we go. And you're gonna share your diagrams with your group mates and see what they came up with. And Lene, I know you're driving, so no worries. Ready. Watching the time, watching the time. This is why we could only do 2. And I get to hush in a minute. I think Gwendolyn might be driving too. "30 more seconds." Because you're taking over at 6:15. sooner if I can do it. All right, everybody's coming back. All right. So welcome back, everybody. Hope you enjoy seeing each other's diagrams. So in a normal class, the next thing we would do is I would have you create one diagram in your small groups that you think best represents the data, and then we would share. And so I'm going to share with you some diagrams that other students have actually done. Okay, and so here's one that's in a tape format or a bar format where they took the bar and divided it up into equal pieces. So you have Rebecca getting 1/3, and then John got 1/4 of what was left. And so Sarah had this part, and they actually reasoned it out to figure out what Rebecca had at the beginning. But here's what they came up with, because she had 24 left at the end. And so they divided up into 3 pieces, and you can solve from there. So that's one. Here's your circle diagram, where Rebecca has this third here. The other 2/3 is divided up into 4 pieces. So John has one part, and then Sarah has 24, and it ends up that 24 is half of the whole circle. How about that? So that's another model. Here's another one, 2 more. Here's an array model. We start off with a square, well, not square, but a rectangle representing the bag. And then here's Rebecca's third. Divide up the remaining into 4ths. That's John. And so what's left is 24. And if you extend all the lines for the grid, you'll end up with 4 in each box to represent the 24. And so that's how they reason that out. This one, it didn't start with the 48, they start with the question mark, but they did sort of a flow chart looking thing where Rebecca got that third. And so they took this one and divided up into 4ths, and John got that piece. So this remaining part was Sarah, which you can see actually is there. Now, here's the interesting thing. You could absolutely do this problem using an equation, but why? When you use a visual and you can see much more about what's happening, you can reason out much more about what's happening. So let's talk. What did you see in terms of engaging, exploring, or applying, or even reflecting in doing this task? Let's have some people who haven't talked yet. You got Tiffany and Valerie. You just unmute and share. Nicole.
The students are asked to explore possible ideas for how to visually represent the language that's in this problem.
Awesome, awesome, absolutely. Thank you. Others? I heard the beginnings of something.
Sorry, I ran to the bathroom. So all I'm seeing is your little 4 model. And what did you notice? So I missed the question.
So no, it was what did you see in terms of these 4 pieces in the Sarah's
In that last problem, right? That we did with
that
the
last
model.
problem, exactly.
Okay, so I see the engaging when you put them in the small group, exploring when they had to come up with an idea as to how to solve the problem and then come up with an idea together to show how they wanted to, model it for people. They had to apply fractions
Mm,
to it, their fraction knowledge. And not only that, just doing those different kinds of models. They had to apply that because I know that they have to learn about them. And then the reflection, I guess when they shared with others, they allowed others to give feedback.
yeah, yeah.
Okay,
Yeah.
sorry.
Love it. No, you're good. You're good.
Okay.
No, that's awesome. No, that's awesome. And one thing we did not do is when I've done this problem as a part of a study and in actual classrooms and with other students and teachers, etc. Another thing that we do in terms of reflecting is to then have a conversation about what makes a good diagram. When you're diagramming for mathematics, what makes a good diagram? Having proper labels. If you have option of colors or patterns, help to indicate different things. And so that's a way of doing reflection with that problem. What makes this a good diagram? And it makes it easy for us to solve the problem. So thank you guys for doing that. So we're going to tie this up real quick. First thing I want you to know is that functional language is not boring. Okay. And so especially functional language in mathematics, visuals are awesome. And one of my favorite people, Andrea Honingsfeld at the Southeast TESOL said this, that using visuals means changing the language density, not the rigor. So you can do higher level mathematics, higher order thinking, etc., and just use visuals to lessen the language density and give more students access. The last thing I want to tell you is that Paul Blankman has this blog where he talks about 7 strategies for teaching math to English language learners. And number 6 is using tools and visuals and manipulatives. And he gives these points that mathematics welcomes visuals. Again, there's nothing in mathematics that cannot be represented visually. All students with sight can benefit. And that's really good. And that's really important. But we have to understand that for multilingual learners, this can be a critical scaffold. It's not just good teaching, but that it's critical for them to have these kinds of scaffolds. Digital models can be just as effective, and that students from different countries may know or use different models. Just understand that may be the case. So with that, we're going to turn it over to Georgia DOE and Jenna.
All right, thank you so much, Dr. Terrell. I am going to share my screen. All right, here we go. Okay, so my name is Ye Na Parrett, and I am the Mathematics ESOL Program Specialist at the Georgia Department of Education. So before I do anything else, I want to say thank you to everyone who's here today, because I actually came from Korea when I was in 3rd grade. And so as a person that went through what your students go through, like your students do appreciate you taking the time out of your summer to learn more about the different strategies that you can implement to help your students. So that being said, I am going to begin. So it's been a while since I used Zoom, and I am having a little bit of a hard time looking at the chat right now. And I really wanted to put in some links in the chat. So I think if you can just give me 1 second. There we go. I'm just going to drag this over here. Thank you. All right. So today we're going to focus on the scaffolding instruction for English learners. But first, we're going to look at the instructional learning plans for the new mathematics standards that are going to be implemented beginning of 2023-2024 school year, which is going to be about a month from today. And so I am going to drop the link to Georgia Mathematics Comprehensive Grade Level and Course Overviews in the chat right now. And if you could open the link, we are going to go to page 5 to the Georgia's new K-12 mathematics standards, grade level and course overviews. So I'm going to look at 1st grade, but you are welcome to choose a different grade if you have your own tab open. All right, let's get started. So The comprehensive grade level overview is an amazing resource for teachers. We are going to focus on the curriculum map and pacing on page 6. And so I'm going to project unit 3 of grade 1. Again, you're welcome to choose your own grade and your own unit. So in the unit comprehensive overview, teachers are going to find unit description, relevant academic vocabulary, instructional learning plans, and so much more. So this is designed so every teacher in Georgia, including brand new first-year teachers, can utilize this resource. So I wanted to highlight a couple of things here. And the very first thing that I'm going to highlight is the instructional learning plan. So it comes with teacher guidance, student reproducibles, and sometimes it comes with something called the Black Line Masters. So if you have, or if we provided something that the teachers may need, but not necessarily for the entire class. So something that maybe the teacher can project to the whole class, that will be housed in the Black Line Masters. And a couple of things that I wanted to point out in the teacher guidance is the standards, common misconceptions, diagnostic assessment, and then the instructional design, which Dr. Terrell has talked to us about, which is the engage, explore, apply, and reflect. And we're going to come back to that in just a little bit. But it also has the student learning support section here. So the student learning support section provides suggested strategies to support the learners before, during, and or after the learning experience outlined within the instructional design. So teachers should use frequent formative assessment information to determine which students need additional support. So the student learning supports provide suggested strategies to support the learning. So in addition to this resource, I do want to talk to you about the scaffolding instruction for English learners that provides mathematics teachers and leaders with evidence-based scaffolds and support for our English learners. So what I'm going to do is I am actually going to drop the link for that resource in the chat right now. And it should look like this. So teachers are going to find ideas on incorporating oral English language instruction into the content area of teaching productive discourse to speak with a partner or a small group. And before I go on, I do want to let everybody know that the WIDA key language uses argue, explain, and inform were integrated into the plans to meet the needs of the whole EL child. So I am going to highlight the mathematics digital learning plans from scaffolding instructions for English learners section here. And since we are focusing on explain of the WIDA's 4 key languages, we're going to look at the second digital learning plan, which is on page 7 of scaffolding instruction for English learners. So explain. Explain highlights language to give an account for how things work or why things happen. As students explain, they substantiate the inner workings of nature, natural, man-made, and social phenomena. So the K-12 mathematics standards set rigorous academic standards for Georgia's English learners. So to help English learners master the K-12 mathematics standards, it is imperative to have resources and scaffolds that more specifically support them in accessing and acquiring grade level knowledge and skills. So this is when we bring the 2 resources together. So earlier, we looked at the teacher guidance of the instructional learning plans, and within the learning plans, we had the instructional design of engage, explore, apply, and reflect. And so when we are looking at the teacher guidance for a unit for the upcoming school year, it doesn't matter what unit or what grade or what unit you are teaching. You can use this resource right here, Scaffolding Instruction for English Learners, to create opportunities to practice the academic language of mathematics for our English learners. So during the Explore section, for example, of the instructional design, teachers can have their English learners use sentence frames to support the learning. It is 6:24, and I am trying to, I respect your time, so I'm gonna talk just a little bit more because I do want to make sure that if you guys have any questions, we'll get to them. But I do want to mention one more thing. So if you have the scaffolding instruction for English learners tab open on your own screen, if you can just go to page 17 and 18, you're going to find so much more information on productive discourse opportunities to write with a partner or small group. So due to the time constraint, and I respect your time, we were able to only really explore a little tiny part of this amazing resource. So I wanted to make sure that I gave you guys the link so you can star it or favorite and take the time to explore it and share it with other teachers, other teachers of English learners. And I am actually going to take the time to introduce the rest of the Georgia Department of Education's mathematics team members. So we have Dr. Snell, who is the Mathematics and Computer Science Program Manager. We have Dr. Swetna, who is one of our secondary mathematics program specialists. And we have Mr. Golden, who is the other secondary mathematics program specialist. We have Ms. Sexton, who is the mathematics content integration specialist, and Mr. Warnicki, our elementary mathematics program specialist. And again, my name is Ye Na Parrett. If you have any questions, please feel free to reach out. The QR code is my digital business card. So I did a great job. We have 4 minutes. So if you have any questions for Dr. Terrell or myself, please let us know. One thing I do want to say is that the 3 reads, Dr. Terrell, that is an amazing resource. So thank you for taking the time to just explain how to use it. So I appreciate that.
Any questions, anyone? I just put my email in the chat as well in case you need to reach out. Questions or comments?
I was just wondering if Dr. Terrell was going to be sharing her PowerPoint with us.
I will share that, absolutely.
Okay, thank you.
I sure will. And I'll also attach the 3 read if you want a copy of that.
Thank you.
I'll attach both of them actually, the Freyer and the regular one.
Just gonna ask if you know of any other professional developments, maybe on the new math standards.
So I think it depends on what county, what region you are in. We are going to be going all around Georgia, doing a lot of professional development, professional learning. We do have the MathCon. I don't know how many of you guys actually signed up for the MathCon that is coming up, like in, I don't know, maybe like 10, 11 days. So that's you're going to learn a lot of information there, but it really depends on the county that you, or the district that you work for. And if you would like, please reach out to your ESOL coordinator or the math coordinator, and then they can reach out to us, and so they can set something up for us to come.
Awesome. Any other questions, you all?
I just had a question. I had posted in the chat about the links. Are they going to be available to us in the presentation? I'm on my phone right now because my computer was acting up. So I wasn't able to open those links.
Okay.
It wanted to download them on my phone, so I would love to be able to look at that later.
Yeah, absolutely. We'll make sure those links are in the email that
great.
goes out.
Okay, awesome. Thank you.
And if you go to Georgia Department of Education and click on mathematics, there is a way for you to get to all of the resources.
Okay,
Yes.
very good. And the links would be just somewhere in that.
Resources.
Okay.
So
Good,
weird.
good. All right.
But I'm going to put them in the email that goes out as well. So
Oh, wonderful.
yeah, no
okay.
worries.
Thank you.
You're so welcome. Well, it is 6:30. Thank you all so much for coming this evening. If you need us, feel free to reach out. And I'm Karen at georgiatsol.org, so you can email me there, and then we'll send out the slides and everything so you can have that as well as a resource. Thank you so much. You guys have a good night.
Thanks. You too. Good program.
Thank you. Good night.